Great. It's my distinct honor to introduce Dr. Sarah Royse. I've been lucky enough to be working with Dr. Royse since she was a PhD student, and I feel very lucky that she has chosen to work with my data, and you'll see why from her excellent work in a couple of minutes. Dr. Royse is a research instructor in radiology. Her research specializes in the etiology and progression of ADRD pathology with a specific focus on African American populations. Dr. Royse uses innovative neuroimaging techniques to assess ADRD biomarkers in relation to exposures more common in these populations. She also seeks to enhance causal interpretations in observational ADRD neuroimaging studies through the application of epidemiologic methods. So I'm going to hand it over to you, Sarah.
All right. Thank you, Annie, and thank you, everyone. So yes, this is my talk. Okay, so I wanted to start today with a brief introduction. So my undergraduate degree is in neuroscience, which I completed from the Ohio State University in 2016. Upon graduating, I came to Pitt to join the Pitt Research Center as a data analyst. In 2018, while retaining my position in the Pitt Center, I began the MPH program in epidemiology here at Pitt, which I then completed in 2021 and transitioned to the PhD program. In June of this year, I defended my dissertation and have since been working as a research instructor of radiology still in the Pitt Center. So considering my background, I'm sure it comes as no surprise that my research interests lie at the intersection of neuroimaging and epidemiology. And I'm specifically interested in simultaneously leveraging sophisticated neuroimaging and epidemiological methods to better understand Alzheimer's disease pathology. And in the bulk of my work to date, I've used this approach to try to interrogate why African American populations are disproportionately burdened by Alzheimer's disease. So in that vein, I would like to use this very short presentation to briefly describe two of my projects in which I have examined this question using this combined neuroimaging and epidemiology lens. So jumping right into the first project, where we looked at white matter injury as a potential driver of AD disparities. So white matter hyperintensities may influence Alzheimer's disease as they are independently associated with cognition, but they may also affect the progression of amyloid and tau and vice versa. White matter hyperintensities may also drive disparities in Alzheimer's as they are generally more severe in African American versus non-Hispanic white populations. However, interrogating if white matter hyperintensities in specific brain regions influence AD is difficult, as traditionally they are derived as whole brain or lobar measures. So to fill this gap, we created a new, more spatially precise method for measuring white matter hyperintensities called unhealthy white matter connectivity, which combines T1, T2, and diffusion tractography MRIs. Unhealthy white matter connectivity in itself is defined as the proportion of white matter connections that pass through white matter hyperintensities for a pair of brain regions. And to illustrate what all of those words mean, I have this graphic here. So let's say we have region A and region B, and there are, can you see you can't, okay. So there's region A and region B here, and we have 1, 2, 3, 4 connections connecting the two of which are passing through white matter hyperintensities. So for this pair of regions, we would say that the unhealthy white matter connectivity variable would be 2 connections passing through white matter hyperintensities over 4 in total, which would be then 0.5. So using this method, we wanted to know, is unhealthy white matter connectivity in amyloid and tau affected regions associated with cognition, and does its influence differ between African American and non-Hispanic white participants? To answer this, we used cross-sectional data from the Human Connectome project, and we derived unhealthy white matter connectivity between each pair of brain regions affected by amyloid and each pair affected by tau. And then we tested associations between each of these variables with cognition operationalized here as MoCA score. And to determine if unhealthy white matter connectivity in amyloid and tau affected regions contribute to AD disparities, we used this epidemiological framework where drivers of disparities between groups are identified by examining group differences in the exposure, which here would be unhealthy white matter connectivity, group differences in the outcome, which here is MoCA, and then differences in the exposure and outcome relationship, which for here would be unhealthy white matter connectivity and cognition associations. And what we found was that more unhealthy white matter connectivity in amyloid and tau affected regions was associated with lower MoCA scores in the whole sample. African American participants exhibited more unhealthy white matter connectivity and lower MoCA scores than those who are non-Hispanic white, but there were no differences in unhealthy white matter connectivity and MoCA score associations. Therefore, we concluded that clinical AD disparities between African American and non-Hispanic white populations may be driven in part by differences in the burden of unhealthy white matter connectivity or white matter injury in these regions, but not necessarily due to differential effect on cognition. And I will finally additionally plug that this paper was actually just published in Alzheimer's and Dementia, so check it out if you're interested. So transitioning now into the second example project where we interrogated perceived discrimination as another potential driver of AD disparities. So perceived discrimination, or the perception of interpersonal judgment, negative attitude, or unfair treatment towards members of a group, is one potential risk factor for AD that has yet to be fully characterized. It's cross-sectionally associated with cognition, but its influence longitudinally and with respect to AD pathology is virtually unknown. Furthermore, African American individuals report higher levels of perceived discrimination across the life course, making this a potentially relevant driver of AD disparities. So we wanted to know, is perceived discrimination in midlife associated with amyloid, tau, neurodegeneration, and cognition in late life? And does its influence differ between African American and non-Hispanic white populations? So to examine this, we used data from the Heart Score and ancillary Heart Score 500 studies, where participants in the parent study completed the everyday discrimination scale in midlife, and those in the ancillary late life study completed imaging for amyloid, tau, and neurodegeneration, as well as cognitive measures, including MMSE for global cognition, trail making test B for executive function, and delayed recall for memory. And we tested relationships between midlife perceived discrimination and each of these late life outcomes. And again, because we were interested in midlife perceived discrimination as a potential driver of disparities, we used the same framework that I mentioned earlier, where we examined group differences in the exposure, which is midlife discrimination, in outcome, late life imaging, and cognition variables, and exposure and outcome relationships, meaning midlife perceived discrimination and late life imaging and cognition associations. We also wanted to be mindful of how selection into the late life study could affect results. So to address this, we implemented inverse probability weighting, which is a method that effectively assumes that we can remove or lessen selection bias by analytically accounting for the probability that a participant will remain in the study based on baseline characteristics. So in the context of this study, and forgive me, I'm going to talk about biostatistics for a little bit, but it'll be so quick. We built a logistic regression model where the outcome was participation in the late life study and the predictors were midlife characteristics that may have influenced study participation in late life. From this model, we calculated the inverse of each participant's predicted probability of late life study participation to be used as weights. And finally, we assessed the associations of midlife perceived discrimination with each late life imaging and cognition outcome, but now using these weights in the model. And so what we found was that higher everyday discrimination scale score in midlife was related to higher trail making test B score or worse executive function in late life. And this was true in both unweighted and weighted analyses. African American participants exhibited higher midlife everyday discrimination scale scores and exhibited lower late life cortical thickness, lower MMSE, and higher trail making test B scores. And the relationship between midlife everyday discrimination scale score and late life trail making test B score was only significant in African American populations when stratified. And this was true in both unweighted and weighted analyses. Thus, we concluded that the influence of perceived discrimination on cognition may be more long-term, specifically on executive function, and that it may contribute to disparities by being more common in and conferring worse executive function in those who are African American. And then finally, I'd like to end just by highlighting some of the goals that I have as an Oscar scholar. So while I have been incredibly fortunate to have received excellent training in both neuroimaging and epidemiology, I don't currently possess the skills that are needed to reach my ultimate aim listed here, which is to successfully lead interdisciplinary Alzheimer's disease research studies. So with this opportunity, I am hoping to develop the skills that are necessary. I'm hoping to develop leadership and management skills and gain an understanding of the best strategies for management in the context of leading these interdisciplinary studies, as well as improving my practical knowledge of academic research operations. And with that, thank you all for listening.